Hello everybody, welcome again with our virtual Fundamental Physics Laboratory, Physics Department, Faculty of Science and Technology, Erlangen University. This is the fifth experiment and it is about Young modulus, which is dealing with the ratio of stress and strains of the object after we apply the force on it. We are going to apply the stress into a copper cylindrical wire at the Young modulus apparatus. To start with, let's define what is Young modulus. Young modulus in physics is actually a numerical constant named for the 18th century English physician and physicist Thomas Young that describes the elastic properties of a solid undergoing tensions or compressions in only one direction, as in the case of the metal rod that after being stretched or compressed lengthwise, it's going to be returned to its original length. Young's modulus is a measure of the ability of the materials to withstand changes in length when under lengthwise tensions or compressions, sometimes referred to as the modulus of elasticity. Young's modulus is equal to the longitudinal stress divided by the strain. So the aim of the experiment is to determine the Young modulus of strains made of the copper. So the object of this experiment is actually a strain, so a cylinder strain made of copper. So you're gonna measure the stress and the strain, and then you take the ratio of those, then you will get the quantity called as the Young modulus. The aim of this experiment is to determine Young modulus of string made of the copper. So you will put your string made of the copper to the left and the right hand side of your Young modulus apparatus hanging on the fixed part or holder, and then you apply the stress, and you will see the strains produced from your stress, and then you will see how they will be deformed, and you are able to determine the Young modulus of your material, which is a string made of copper. Okay, now what is the materials and tools that we are going to use in these experiments? So first of all, you're going to use the Young modulus apparatus. And the Young modulus apparatus, you're gonna have two paths. The first one is the static path and the other one is the dynamic one, which is you will apply the stress and strains on these parts. So you need to make sure that before you apply the stress, then the water pass here should be in the level. And then when you apply some masses underneath and the material has got the stress, then it's gonna be a bit tilt. So you need to put it back into level conditions. So that's what you need to do on the Young modulus apparatus. As the materials, you're gonna use the copper strings, so in specific of radius, and as well as masses, because you're gonna use masses to apply for the stress. So how to carry the experiment out? But first of all, you need to check the level of both left and right strings on the Young modulus apparatus. You need to look very thoroughly the water pass, whether the bulb is at the center of the level, so indicating that it's in a good level positions. Second of all, you need to measure the initial length of the string on the right hand side, which is the path that you will apply the stress on it. Then you record the positions of the non-use manipulator of the water path. So remember, you will see the non-use scales of this part. And then, third of all, you could apply the stress by putting some masses on the right pant underneath the right string. So by doing so, you will see that your stress will produce the strain. So the deformations of the materials you're able to investigate. So it's going to be very helpful for you to replicate the measurements. So you need to redo it again and again to apply more stress and more strains, so you can have an idea how the deformation will be and what is the plastic limitations of your samples, which is your copper wire, which is very beneficial when you are doing your linear regression calculations. You will see that the level of both strain changes due to the stress we applied and strains produced along the wire or the string. Then put the level position back and record the positions, the new positions. The difference between the initial and final positions is the additional length of the string due to the stress from the hanging masses we applied underneath. And then add a few more masses, then you will see more stress and more strain. And then release all the masses down and redo it again for the second measurements as your applications. Here is the data set you will have after the experiment. The first one is the length of your wire or string. The second one is the radius of your wire. In this case, you are not actually measuring the radius. You will be measuring the diameter because you are using the micrometer screw gauge. And then you will have the mass here, which is all of the masses you applied for the stress. And then you multiply it by the gravitational constant, so you will have the force you applied into the system. And then you will record the initial position before the stress applied and after the stress applied, which is the final positions. So you will read all of these two positions coming from the manipulators, which is you need to take into account the positions of the bulbs on your water path. And then you take the difference of those, and then you will get the delta L, which is the deformation of your samples. Be mindful of the units here when you need to compare with some references. So please make sure that you convert all of the unit accordingly, and otherwise your value is going to be funny if you compare to the reference. Not because you are not doing your experiments incorrectly, but just because you convert your units incorrectly. And then here is the task for students after they got the data, and then they need to evaluate two things here. The first one by doing the linear regressions of your data, the relationship between the force you applied and the delta L or deformation of the samples produced due to the stress. You need to draw the graph of these functions, then do the linear regressions for the data set. Then you're ready for so you're ready to determine all the coefficients on the linear regressions equations you got, and then you could interpret their meaning as well. Secondly, after all, you will get to determine the Young modulus of copper string on the experiments and assigned how close would your calculation be relatively to the reference. So you need to take the relative errors of your measurements in comparisons to the references. Okay, so these two tasks you need to perform on these experiments based on your dry data coming out from your assistants. Okay, I think that's all for today. Thank you for watching and listening. Good luck for your calculations and evaluations, and see you later.